Hi everyone, welcome back to Spring into Math 7. I'm Mrs. Campbell, and today we're going to be talking about ratios, rates, and unit rates. Let's get started. All right, so let's start out with a definition of what a ratio is. You might want to write this down. A ratio is comparing a pair of non-negative numbers that have the same unit of measure. Neither of the numbers can be zero. And a ratio can be written in different ways. It can be written using words, 5:7. It can be written using a colon, 5:7. You use the colon there. I will still say is to 7. Or you can write it using a fraction bar, as I have it here, 5/7. Now, a couple things that are important that I want to point out. A ratio is never changed into a mixed number. A ratio is not a fraction, it just looks like one. And ratios have the same label. We're basically comparing same things when we're dealing with ratios. Okay, let's take a look at an example of a problem using a ratio. A shade of green paint is 2.5 quarts yellow paint and 1.5 quarts blue paint for 1 gallon. If you wanted to get a 5-gallon tub of paint in the same color, can we use ratios to show the answer? So what we'll do is we'll start out by writing the ratio as yellow to blue. Then we'll plug in the numbers that were given in the problem, 2.5 to 1.5. We know that, that's written in the problem. And then what we're going to do is we're going to multiply both 2.5 and 1.5 by 5. Why? Because we're ultimately aiming to get 5 gallons. Then what we'll come up with is 12.5 quarts and 7.5 quarts of each yellow and blue paint to get our 5-gallon tub. And that's how we work with ratios. Now a rate, and you also might want to write this one down, a rate is a ratio that compares two unlike quantities. A rate can be written in the same form as a ratio, but rates have different labels. You might see something like 3 miles in 25 minutes. That would be a good example of a rate. Here's another example of a rate. Mary finished a 10-mile race in 56 minutes. She wants to predict her time if she were to run a marathon, which is 26.2 miles. What is her predicted time for her marathon? So we'll set this up as miles over minutes, and that equals 10 over 56, because the problem tells us that it takes her 56 minutes to run 10 miles. Now, using what we know, we can identify and figure out how long it would take her to run the 26.2 miles. So I have 26.2 over question mark because that's my unknown. How long, how many minutes? So basically, all we have to do is ask ourselves, 10 times what number is 26.2? Well, that's actually pretty simple. You could probably do that using mental math. It would be 2.62. Okay, so now we are going to multiply both 10 times 2.62, which gives us 26.2 miles, but also the 56 times 2.62, and we get 126.56 minutes, and that's how long it would take her to run the marathon. Okay, now we've talked a little bit before about unit rates, but let's dig a little deeper on this one. A unit rate is a rate, which means it's actually also a ratio, with a denominator of 1. And that's the most important thing to remember about a unit rate, is that the denominator is 1. The word unit actually means 1. For example, miles per gallon or ounces per dollar. The word per means for 1 unit. Let's take a look at an example of a unit rate. Apples are 99 cents per pound. Is this a ratio rate or a unit rate? So I've set it up as price of apples over number of pounds and 99 cents over 1. So basically, we're comparing the price of apples to the number of pounds. The key in this problem is the word per. It tells us that we're comparing to how many? 1. The rate has a denominator of 1, so we know that that will be our unit rate. All right, everyone, that just about wraps it up for this lesson. Thanks so much for joining us, and we'll see you next time.